with before we get into the lab work. Hold on, yeah. Okay, so first thing is I want to share with you the hold on, sorry. Oh no, nak bersin tapi tak keluar, so stress pula rasa. And never mind. So if you guys have a look, okay, let me open my OBS. Where is it? Lesson plan, not so much. Boleh lah kot lesson plan. Ada tak? Tak ada. We'll look at this. We change it to hold on, saya masih lagi not good at OBS and apa ni? With OBS and sorry. To open this first and then
Memang blur sir.
blur as in
Belakang tu.
tak sharp.
Tak sharp.
I think this is more on the internet.
I see.
Tapi what you can do is open on your side juga lah, the lab manual and everything. But the one that I'm trying to open now is the Google apa? Dah buka tapi Google punya okay, sorry. I need to open the bukan mana? Link summary. Alright. So this is the link summary yang I want to share. I've included a new sets of document. So registration, semua saya dah yang ni the latest one. So make sure you are enlisted in the in the class to make sure that nanti tak ada apa-apa issue lah in terms of your course assessment and whatnot. So make sure everyone their names is in there, is in the link here. This is the latest one I just got just now from Sims. Sorry. And then I've also added lesson plan. So if you hover over it, you can click the lesson plan link. It will bring you to here. Let me, okay, so I did. So let me show a bit. So if you look at the lesson plan, we are currently in week 2. And we are going to perform the introduction and to embedded system lab for today. And then we'll be having week fundamentals of hardware for the next weeks and so on and so forth lah. So every single week we'll be doing a new lab until week 12, where on week 13 to week 16 you'll be focusing more on mini project presentation and mini project lah, or for you to do your mini project. Okay, I would like to highlight that okay, let me share the course outline first. Okay, if you recall last class I shared with you that your assessment is based on lab session 73.5 and application of your mini project, which is 26.5. So main application is at the end here, week 13 to week 16, but the most carry mark assessment will be coming from lab session 73.5. Okay, the reason why I'm highlighting you here is because lab works and short report, you need to submit the EXP1 lab sheet. For this lab, for this week, is EXP experiment 1 lab sheet. So this is where I gauge your lab works capability and also your short report lah from here. So as you can see, there's a coding. You need to paste the result of the code that you've put in. You need to paste it here. Again, sorry, again. result and output, you have to use your creativity to show to me that what you have done produce this result, produce this output. So you need to make sure I see all the proof that the circuit that you have done, the code that you have done, uh, work as per intended. Okay, so you need to use your creativity lah to show to me. You need to prove to me that the work that you've done resulted as per what is being expected. Okay, you'll have one, two, part B. Part B, there are two parts. Okay, hold on. And also part C and discussion. Okay, you need to. This is where. Hold on. Yes. So discussion is where your short report will be. Where I'll judge your short report, as well as the schematic diagram and the voltage. This is basically the question that you'll be answering at the end of the lab. Okay. So I want you to know that this lab sheet is being completed by individual. That said, at the end of the lesson plan, if you see there's a mini project, and I've mentioned earlier last week that you need to form a group of 2 people in one group. And of course, if we have more than, if, sorry, hold on, let me open the links, BA and BB. So in our class right now, we have BA 12 people all in all, and then for BB, we have 11. So since we are in the same class, you can mix. It's better that you mix lah kalau BA, BA, BB, BB. And since BB ni ada 11, you only have 11 people. So there will be one group that have 3 people in that group. So if I'm assuming correctly, no. So only 2 people. Ni, okay. Rewind back. You'll be forming a group of 2, except for group BB, where you'll have maybe one group that have 3 people, 3 person in that. Just one group only. And you need to update the name of the group in the Google Classroom. The link already included in the summary link. You can get to your respective Google Classroom. Since BA and BB everything is almost the same session, so there's no point of me creating a Google Classroom specifically for you. So that's why I just lump sum put it in here, BA, BB. The same with CA and CB. So all your lab assignment, all your lab sheet, all your any kind of test or quiz or whatever I'll be using this platform for you to submit and to disseminate any kind of info regarding that submission. Any kind of submission will be through here. That's it. I want you to list down group members here. I'll be putting the post here. Group members. So for example, G1, group 1, nama siapa, 2. So I want you to fill this up as early as possible, because even though you're doing your and so forth, ni tambah lah nanti so on and so forth bawah tu, group 1, group 2, group 3 and so forth and so forth. Biarkan saya panjang-panjang. So you can add a comment here lah in your apa nama BABB punya classroom. That said, you'll have to go back to the course outline. Where's the course outline? Did I close it? This one. So if you see here, okay, for short report and lab report, you'll be submitting it every. I give you, saya tak nak bebankan awak lah subject lab kan. Memang standard, even LIC pun minta sebenarnya habis je kelas terus submit short report. Tapi saya tak nak bebankan awak. Saya bagi masa. Kalau contoh macam hari ni, kelas hari Ahad, hari apa saya tiba hari Ahad, kelas hari Isnin. So you need to submit your report last is Sunday, each minggu tu, Sunday before 12 p.m. So midnight before 12 midnight, you need to submit your lab report. Sorry, anak bersin tapi tak tahu bersin tak. I'm not well, jangkit anak hingus semua dengan batuk. So that's it. Korang kena submit your lab report, lab reworks dengan short report by Sunday 12 p.m. So macam contoh hari ni, our lab session. So you need to submit your lab report of lab works dengan short report by this Sunday before 12 midnight. So kalau tengok lab sheet ni tak banyak pun awak kena isi. You just paste on the coding that you have written, the result and output. Make sure everything is comprehensive. Don't just simply copy paste and then biar macam tu je. You have to make sure I understand what you did. Sorry, what you did is reflective of the journal apa nama ni lab manual punya requirement lah, apa yang they expect from you. So kena baca. The same goes, each and every single result and output ni kalau buat terus memang by hari ni boleh settle lah. Kalau korang habis je lab ni terus copy paste, siap lah. Cuma tinggal bab discussion je. Bab discussion ni special. I expect you to use your own words. Of course, you can discuss between your kawan-kawan semua, tapi kalau dia salah ataupun markah dia kurang, that means markah awak pun kurang lah. Jangan expect ayat sama, markah dia kurang, markah awak lebih, ataupun markah dia lebih, markah awak kurang, awak marah-marah pula, tak boleh lah. So you have to use your own words to answer these questions, as well as ni lah, the schematic diagram, voltage and the request ni. Ni basically menjawab soalan ni. Okay. So this is individual submission. This lab sheet, you need to submit it to comply to the lab works and short report submission for every week. That said, when I go into the experiment today or the weeks after this, I expect for you guys to open your camera because I need to gauge, I need to give you this mark, the one that has the what you call this, lab practical assessment and whatnot. So I need to make sure that because I will be, for those yang selalu tutup kamera tu, I'll typically choose them to make sure that they know what they are doing. Because tadi kelas lain tadi, yang lain semua buka kamera, so nampak macam dia buat kerja. So I can gauge from there lah. Tapi those yang tutup kamera tu, saya tak tahu dia buat ke tak ke, dia lambat ke apa ke, kalau saya tanya pun senyap. So that's why I'll ask him or her who tutup kamera tu to show to me where their progress is lah. So jangan tutup kamera, buka kamera, so that I can gauge you without asking you. Alright. So I need to give you marks here. So while we are doing the lab, I need to gauge. So I'll expect you guys to open your camera while the session, our class session is being held. From minggu ni sampai ke habisan. Ni memang Profesor UiTM tegur semua orang sebab this is what I take juga lah. Kalau ada audit, it will not be just me who will be having problems sebab tu saya buka kamera ni. Sebelum ni, saya lepas saya tak buka pun kamera. Tapi kalau ada audit, they will ask ni lah. Dia akan appropriately panggil untuk interview. Okay, that's it. Untuk kita dah tackle lab works dengan short report. So ada satu lagi, this thing called long report. Long report ni is kalau kita tengok lesson plan. Long report ni, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Kita ada 9 lab. I'll choose either of these lab for you to submit the long report. Meaning, awak punya long report for lab works, hanya satu eksperimen saja yang awak kena submit, which I will choose later on. Not today, later on. Okay, so I'll announce it earlier lah. Tak adalah macam hari ni baru nak buat lab, hari ni baru nak announce suruh buat lab long report. Saya beritahu awal sikit lah. Nanti saya decide which one. So that long report, you have to follow the format, long report format. Hold on, let me close this one. Where's the long report guideline? You can find it in the link summary. Yes. Okay, so as you can see, dia punya ni panjang sikit lah. So I expect you to, again, ikut LIC, he asked me to give you only 1 week for long report. So I have to comply with that since short report pun saya bagi seminggu juga. I think it's a bit lenient lah bagi saya. Saya bagi seminggu juga. But I'll try not to kacau during test week ke ataupun exam week. Saya tak nak kacau lah time nak submit long report ni. I'll try my best not to clash with that. Okay, apa ni? Okay, apa lagi announcement saya nak cakap? Okay, yang mini project long report ni don't worry for now. I'll be briefing you the necessary detail as we go along once I got a clearer picture. But for now, kita focus more on the lab session lah. Alright, so any question so far regarding maybe tak boleh register dekat ni ke, future ke, tak boleh masuk lagi, so tak boleh nak masuk attendance. Let me double check.
No, sir.
Yeah?
No question.
No question, alright. Ni ada yang tak sign attendance lagi, make sure sign your attendance. This will be recorded. And besides, lab ni kalau terlepas lab, for me lah, saya dulu diploma when I was at your age or maybe younger. I'll try my best kalau nak skip, I'll skip class but not lab. Lab works kalau awak skip, chances are awak kalau macam macam lab ODL ni alhamdulillah lah so far okay, tapi macam saya cakap lab works tu dia punya carry mark is more heavily on during the lab tu. So kalau awak miss that lab session, awak kena tanya diri awak lah kat mana nak dapat markah 73.5 tu, because you have to remember kalau awak mini project tak perform pun but you still carry your weight dekat lab session ni, awak dapat mini project awak 10 markah pun, you still get an A tau, 83.5. UATM 80-80A. So kalau awak ada masalah dekat lab session ni, mini project awak kata awak perform macam mana pun, katakanlah lab session awak hanya dapat 50, dia dapat 26.5, takkan dapat A. So that shows how important. Ini strategi lah saya melepaskan diploma saya dengan CGPA cukup makan is dengan cara macam ni. Maksudnya saya tak nak repeat, saya nak grad je, nak habis cepat kan. So itulah. Tapi of course menyesal lah lepas tu kan, sebab pointer rendah kan, cukup-cukup makan je, kerja dead end job apa semua. So end up saya balas balik lah time degree. Okay, but my point that I want you to take is that don't skip lah lab session ni. So that 73.5 ni awak secure kan. InsyaAllah kalau awak settle lab session ni tak ada issue. Trust me, I'm giving you a very lenient marks. Kalau bab lab ni saya try sebaik mungkin lah. Sebab my point in lab is for you to understand how to do it. Not so much on what your ability to goreng all your report apa semua tu. I want to make sure that you know how to do it. Penting. Okay. Okay, that said, ada announcement lain ke so far? No. Okay, tu je lah kot. So make sure always check your link summary ni. I'll be updating anything, ada apa-apa issue ke, I'll be updating it here. Every single info you can get it here. Okay, now we'll start with experiment lab 1. Okay, dia boleh tutup. Okay, make sure Google Classroom, fill up your attendance, your group members. Alright, tu dia. Sekejap saya tukar balik saya punya OBS punya display ni. Hold on, give me a second. That manual, and then this one will be, is it? This should be the one. Fresh, look good. Okay, so we'll start. But okay, I put the what you call that? The integral cat tu on the right side so that korang boleh nampak circuit. Yang lab manual tu saya ada gambar muka saya pula tepek kat situ sebab semua orang pun boleh buka lab manual dekat their own computers. So I guess it's better this way lah kot daripada saya conteng yang sebelah sana, saya tutup pula muka saya. And bukan saya nak glamour nak tunjuk muka ni, bukan, ni sebab audit lah nanti. Okay, we start Bismillahirrahmanirrahim. Siapa baru masuk ni? Terlajak tidur siang lah apa? Okay, apa tadi? Saya nak tengok ni, give me a second. Apa benda saya nak buka ni, lab manual, mana lab manual? This one. Okay, before we start, I would like to know, I would like you to know, before we start every single experiment, what my advice is to you, since everything is online pun sekarang ni dah tak susah, ambil masa malam sebelum ke, petang tu ke, baca sikit bab theoretical part ni. Saya akan membebel, of course, tapi bila awak dah baca sikit, kalau dengar saya membebel tu, at least dapat more than if you have no prior knowledge at all, and you join my class, and saya membebel seorang-seorang kat depan, chances are you only get what, 10, 15 or 5% je apa yang saya nak sampaikan kat sini. Although I won't say because kita tak ada test, tak ada exam, tak ada apa, there won't be any question on it. But understanding Arduino ni is crucial for your FYP later on. Part 6, part 5 nanti. Kalau bagi saya lah, I think this subject is very good for you guys because FYP kalau compare to your senior punya batches, tak ada langsung main Arduino ni. Memang totally time FYP itulah dia baru nak pegang Arduino. So mulalah menggadah faham coding ke apa benda, kenapa buat setup, kenapa buat loop, benda ni yang akan kabut lah dengan subjek lain lagi. But now memang you guys has the privilege of not only Arduino but all the other supporting software yang korang boleh guna for your FYP later on. So I think it's a good subject and therefore it's good lah kalau you can take a lot of things from what I'm trying to share with you today. That said, of course saya akan terpaksa membebel lecturer about theoretical parts ni. So bear with me lah. Nak minum air, minum, tak ada halangan. Even though kamera buka, boleh je minum air sebab saya pun minum air. Saya sebenarnya tekak, tak sedap ya. So tak nak kena minum air. Kalau tak nanti kan teruk batuk saya. Okay, kita start dengan experiment 1. Basically, we will be looking into embedded system. Kenapa Arduino? Sebab Arduino is a computer yang membolehkan kita interface not only hardware but also a software to comply to perform a specific tasks. Tu keyword dia. But tak apa, kita tengok objektif dulu. Basically, objective of this syllabus experiment is to allow you to understand what is embedded system concept with a microcontroller and to construct an embedded system circuit that has an input and output peripherals. And finally, for you guys to be able in real time, or not to say real time lah, but basically almost real time, tapi menggunakan simulation of programming with input and output. Sebab if you recall part 1, korang belajar C programming dulu, memang ada input output tapi totally virtual monitor macam tu lah. Even ni pun simulation, ya betul, but dia punya relationship dengan real world tu almost 80% real lah. That means kena ada wire, kena betul-betul proper terminate polarity and whatnot. So dia punya impact of understanding programming with real input and output punya relationship tu is much more significant, which you guys will be experiencing this a bit later lah. So what equipment that you would require moving on, I think in the future dah korang tak payah bawa buku nota dah kot, most probably semua pakai personal computer. Given that our lab pun banyak yang tak ada projector, tak ada projector lah, apa lagi yang nak pakai kan, TV smart TV ke, kalau ada pun certain classroom je. So I think moving forward after ODL ni, I think you guys will be bringing along your personal computer. So for those yang B40, I'm not saying that ni, tapi kalau boleh cuba usahakan menggunakan yang, kalau korang ada PTPTN lah. Kalau ada duit zakat, cuba dapatkan. Tak perlu PC canggih-canggih pun for your diploma punya pengajian ni. Just a simple, even second hand punya laptop pun boleh. Saya boleh advise lah kalau kata rasa sembab je apa sebab okay, bear with me, korang ni level is on what you call apa nama, survival mode sahaja dulu, belum bekerja lagi, and so I understand if you are on a tight budget, your parents on a tight budget, you don't have to flaunt your apa, siapa yang mampu tu alhamdulillah, siapa yang tak mampu tu jangan malu lah, pakai je apa yang ada dulu. I mean uh, tak payah nak malu sangat lah, zaman sekarang ni semua orang pun faham kan, apa COVID lah apalah, mak bapak ada yang hilang kerja apa semua, so I think your friends pun faham lah. Don't worry about that. If you have any issue, if you bought a second hand laptop and ada problem dengan tu, if kedai tak nak support ke apa ke, saya boleh try tolong lah. Okay, that's it. Kita tengok introduction ni. What is embedded system? It is defined as combination of computer and hardware, and software to perform a dedicated function. Maksudnya, if you have, for example, washing machine, it has a dedicated computer dalam tu. Jadi sebenarnya komputer ni, we call it a computer, tapi sebenarnya is a microchip dia sebenarnya. Korang kalau belajar PLC ke, korang belajar micro P ke nanti, sorry, korang akan nampak lah yang microchip kecil tu je. Even nantilah Arduino tu nanti kita tengok. The brain tu yang control everything in that particular, I mean dia ada hardware dia melibatkan chips tu and all the component, the motor and whatnot, and also software, yeah, where you code, bukan code lah, program dia punya apa nama, PIC, PLC ke whatever control software yang you want to use in that chips, and then it can only perform a dedicated function. Maksudnya your washing machine hanya untuk basuh baju. Awak tak boleh guna washing machine awak untuk vacuum rumah, tak boleh guna washing machine awak untuk main komputer. So it is a dedicated function only of a computer and of a computer hardware and software. It can be designed with several additional parts, either mechanical or electronic. Ni nak tambah dia punya accessory sensor semua tu lah. Basically what is being said there. And it involves microcontroller and software that can be written in codes, whether it's in, hold on it can be written in either assembly language or high level language. Assembly language ni, for those yang who doesn't know, who haven't had a chance, assembly language is something that macam microprocessor, microprocessor lah basically, nothing much pun. Microprocessor maksudnya low level language. Low level ni bukan maksudnya dia apa macam main game, dia level rendah ke apa, no, bukan. Dia maksudnya dia main dengan electronic saja, between one chips to another, whereby kalau high level language is between computer and a human. Bukan maksudnya siapa yang antara assembly language ataupun low level language maksudnya dia tak pandai ke apa, no. Expertise tu lain. So assembly language more towards assigning microprocessor punya pins tu nak connect ke mana, dia punya next line apa, buat apa. Whereby high level language untuk kita interface dengan kita so that kita pun faham. Okay, some examples of actual system for embedded system may involve digital camera, digital phone, ticket machines, your handphone, your 3DS, your apa baru ni, Steam Deck, tu semua embedded system lah tu. There are many microcontroller series and name which it depends on the manufacturer produced by the of the microcontroller. So macam Arduino, by Arduino lah, Arduino Uno semua tu being developed by Arduino, and then Raspberry Pi by saya tak ingat apa nama company dia, and then ada Freedom Board by apa nama, Freedom KLZ lah. And recent years, there are several type of development boards that has gained popularity of embedded systems such as Raspberry Pi, Arduino, and BeagleBone Black. I haven't had the chance to play with BeagleBone Black, but I would I would have experience in Arduino, FRDM board, and also Raspberry Pi, but a little bit only lah for Raspberry Pi. Most of my works is based on Arduino. Yeah, this is Arduino. Kalau dia tak AI ni tak blur out kan, yang OBS ni pakai AI signal processing ni, so dia nampak warna hijau, dia terus diingatkan green screen. And apparently Arduino ni dia punya color yang saya ada ni is a bit green, so dia ingat tu macam green screen lah tu. Terus dia padamkan, tak apalah. But Arduino saya ada around 4 to 5 Arduino board available. Memang saya buat project menggunakan Arduino. Even my research, I built a wheel mobile robot yang mana kononnya untuk apply AI so that they can handle jalan licin. So I built a WMR or wheel mobile robot using Arduino. Tapi saya tak pakai Arduino Uno lah, saya pakai Arduino Mega because I need to use several parts of sensors and motors. So then we look into microcontroller. So this is basically Arduino ni dipanggil microcontroller. Embedded system tu is the whole thing, the whole ecosystem. Maksudnya Arduino, sensor, motor, whatever output yang you letak, tu semua is embedded. Tapi if you're talking about board saja, this is the microcontroller lah, Arduino. So when you're talking about microcontroller, it is actually these chips ni. Yang tengah-tengah yang panjang ni. Siapa yang main komputer tu, you should be able to understand what is CPU is. So this is the CPU for Arduino. So benda ni tak apa, nanti saya explain lagi. Kita tengok dulu basically this is the microcontroller lah. Kalau Raspberry Pi pun tu pun microcontroller juga lah. It is basically a small computer with an integrated circuit that performs certain functions in electronic circuit. When all the necessary components in a small computer are found to be an embedded system, it can perform specific tasks yang user define. Okay, tak apa, itu baca je. So yang Arduino kita pakai Atmel punya processor. So dia kata microcontroller ni lah microcontroller tu. Tak, saya nak letak depan, dia hilang. Dia AI ni dia detect as green screen, so saya tak boleh tunjuk. Ada certain distance je baru dia. Ataupun saya tukar dia punya ni. Sekejap, hold on. Tadi saya pakai yang AI lain maksudnya. Give me a second. Video capture, filters, media pipe saya pakai. Boleh? Media pipe okay sikit. Close. Okay, so this is tadi okay. Dia detect green screen juga lah. Tu. Ni ni. Ni. Ni this is the microcontroller panjang ni. So the whole board kita panggil Arduino Uno. Dia punya specific brand model ni is Uno. Tapi microcontroller tu is the chips. So if you look at your PC, siapa yang ada desktop, CPU tu lah is what we call as microcontroller in the sense of kita punya subjek ni. So manufacturer microcontroller ni ada several je, tak banyak dalam dunia ni, Motorola and whatnot. Tapi when we are talking about microcontroller yang kita pakai untuk DIY project, memang Atmel, Microchip Technology, Freescale and several others lah. And all microcontrollers developed have their specification according to the user requirements. Consists of component. Basically, komponen dalam Arduino ni kita kena ada CPU, which is the microprocessor, yang mana all the logic is being or decision is being kita akan embed dalam ni. So dia yang akan jadi brain. Memory untuk simpan, untuk cepatkan proses transfer of instruction. Timers and counters for you to control the output, the rate of receiving and sending instructions. I/O ports to interface dengan luar, sensors or motors and whatnot. Serial communication interface, which is serial ni yang TX tak nampak, tapi bawah dalam tu nanti ada dia punya gambar dia dah lukis gambar dalam tu, nanti Arduino Uno saya tunjuk lah. So serial communication interface ni untuk for you to communicate dengan any kind yang memerlukan I2C punya communication lah. Bus yang menggunakan I2C punya bus, macam LCD display, macam apa lagi ya. Typically orang gunakan untuk LCD display lah untuk display data. And then ADC for you to use your sensors to be to be input to as an input to the microcontroller for them to read that input from analog form to digital, sebab komputer hanya boleh faham digital, whereby kita manusia kita hanya nampak in terms of analog. So we need to convert that analog to digital, and then DAC bila dia dah compute, dia dah calculate everything, and the logic instruction indicate that they want to, you need to the motor need to rotate at this certain speed. So dia kena convert analog digital yang dia dah kira, microcontroller dah kira tadi tu, balik menjadi apa nama, analog. Sebab motor dia tak faham 1001 111 tak faham. When we are talking about digital is 1000 111 0111 tu nombor digital. Whereby analog yang nombor kita measure lah, which is 2.03 milliamp, 21 degree Celsius, 22 volt, tu analog. Tapi komputer tak faham 22 degree Celsius semua tu, dia hanya faham 111 0 111 111 0 0 0 and whatnot. So dia akan convertkan lah. Dia hanya faham bit atau byte. And then interrupt machine ni, let's say for example korang buat satu menu display, so selagi user tak tekan anything on the menu, so the menu will keep on displaying the LCD lah. So if you press macam contoh ATM, awak tekan duit berapa banyak nak keluar tu, tu yang awak tekan tu startlah interrupt dia, so dia akan bawa ke tempat yang lain, menu yang lain for example, ataupun keluarkan special instruction based on apa yang awak tekan. Itu guna interrupt. And system bus is kalau tengok dekat atas board tu, dia ada macam line daripada sana ke sini. So you can imagine system bus is like a highway lah for data travel ataupun current travel. Data tu pun sebenarnya current je. Tapi basically system bus is the highway lah. So kalau tak ada highway, data tu tak boleh bergerak lah ke tempat yang dia nak pergi, which is sensor tu tak boleh nak faham, ataupun microcontroller tak boleh receive data. So something wrong lah dengan system bus. Okay, dan kita tengok Arduino. Okay, yang papa panjang-panjang ni tak ada apa, cuma dia nak bagi tahu typically construction dia macam ni lah. Ada gambar bawah tu, kalau tengok dekat menu lab tu, ni lah sama lah dengan apa yang saya pegang. Cuma yang saya pegang ni yang original. Ada satu lagi tu yang China made punya. Yang China made bukan maksudnya tak bagus, cuma dia murah lagi, cuma dia punya spek tu ada lari-lari sikit lah daripada yang Arduino buat ni. Sama ada lagi bagus ataupun lagi kurang, tu tak boleh nak cakap apa lah. Tapi dia kalau menggunakan microprocessor yang sama, shouldn't be differ that much lah. Cuma harga dia sangat-sangat murah. For you guys nak buat FYP nanti, saya advise beli yang China tu pun dah cukup dah. Tak perlu nak beli Arduino Uno ni. This one will be around $40, yang original Arduino Uno ni. Tapi kalau yang China tu, typically it will cost you around 30 something lah. Murah pun dalam RM5 lah paling murah. Ni siapa boleh join ni. Okay, so if you can see dalam menu lab tu, ni contoh, saya zoom in. Tapi bila saya zoom in jadi besar sangat pula, kita apalah. Tapi masing-masing pun boleh buka lab menu, tengok. So USB tu kita connectkan dekat yang metal besi ni. Ni kalau nampak. Mana ni? Ni. Saya kena letak kat muka saya baru dia ni. Baru dia tak padam. Ni besi ni. So samalah rupa dia dengan yang dalam circuit dalam tu. So ni USB tercocok. Kita ada dua power option input, sama ada USB ataupun DC jack. DC jack ni bagi saya is much more preferable lah, sebab USB ni selalunya current dia tak cukup kuat. Takut nanti kan awak pergi hantar ke mana-mana sensor ataupun motor ke, takut dia tak boleh lah power up. So it's better korang pakai DC jack lah kalau korang dah sampai tahap buat level FYP project nanti. And then dekat Arduino Uno ni nama dia Uno. Basically dia ada a few other jenis Arduino. Dia ada macam saya pakai Arduino Mega, and typically orang kalau dia main dengan wearable apa DIY project tu dia yang kalau nak pasang lampu kat sini ke apa ayat ke, macam contoh nak keluar apa corak ke kat lengan ni kan, so dia letaklah LCD screen kat lengan ni, so boleh pasang Arduino Nano. Dia kecil je Arduino Nano tu, dia korang boleh lah jahit kat sini ke kat mana-mana lah, pandai-pandai jahit, and then wirekan dia and then some battery, you should be able to get apa ni lah, some sort of patient statement lah, I guess, kalau nak buat wearable technology. Maybe lah kalau ada yang nak jadi apa, nak buat tudung apa, boleh bagi signal ke kan, jadi naik motor signal boleh bagi kat tudung, tek kiri kanan lah, tu siapa nak buat lah. Ataupun apa tudung kedai tom yum RGB. Anyway, Arduino Uno yang this is one typically yang korang pakai untuk make FYP. Kalau korang buat robot yang tengok saya dah janji nak banyak cakap, nak practice my English, tapi end up saya cakap Melayu. Okay, so back. So if you want to build a robot, typically this won't be sufficient sebab cost digital pin that they have isn't that much. They if you take out PWM, if you take out serial communication, if you take out interrupt pin, you will only have 3 pins available for you to connect to a sensor or a motor output. So tak boleh buat banyak lah. And then some more, it can only support to a certain range. Tak silap saya 1 milliamp current saja in total yang dia boleh supply kan. That means if you have sensors to power up, and if you have motor, if you have LCD display, even though you only use 3 pin, 2 or 1 in analog, 2 in digital, chances are the motor won't turn lah sebab tak cukup current. Sebab ni hanya mampu 1 milliamp saja. There are workaways, of course, but that one is advanced level nantilah baru korang belajar. But I want to say is Uno, Mega, what you call that? Pico bukan Pico. Satu lagi apa? Micro, sorry. Micro and Nano, their range of operation isn't that different, but it's more on the function lah. Kalau Nano ni untuk simple prototyping should be enough. For Mega, for a big project, then it should be sufficient. But for a simple that you want something that you want a small version of an Arduino controller, then Arduino Nano should be also good. But I haven't had a chance to play with Arduino LilyPad, so I can't even picture how Arduino LilyPad is. But basically there is a thing called LilyPad. I haven't had the chance to try it. So if you look at the picture, figure 1.1, you can see there are 2 sources of power, which is USB connector and power port, like I've mentioned. These are the only 2 ways that you can use to power up your Arduino Uno for your project. And then there's a voltage regulator. The function of voltage regulator is to make sure that your sensors or your any kind of equipment you attach to the Arduino Uno and Arduino Uno itself not to be blown up in case there's a surge of current or voltage in the supply line. So that's the function of voltage regulator. Oscillator for the timer, cycle similar to timer C5555 apa nama tu. And then reset switch if let's say you have a problem with your prototype and you want to reset the code, you can just press it and everything will be back to default settings. So everything will be empty. And then TX, RX, LEDs is more towards to indicate whether there's an activity of data transmission to and from Arduino Uno. And then again, microcontrollers is the long bar there, the bottom one. So that is called the microcontrollers that I keep on saying just now. This is also called CPU. This is the brain power that everything that you code will be burned here, microcontroller. And then the analog input pins at the bottom of the microcontroller. Is it like this? Oh, something like this. So this one is where you get your data from. Meaning if you have thermal sensors, if you have temperature sensors, you will connect it to here, to the analog input pins. Power is for you to power up all the sensors, all the motors that you want to draw power from. So you should get it from here, 5 volt. But we are talking only on voltage. Current is from the voltage source. It's up to it's upon demand. Now, I am aware that you guys haven't even been to a lab in previous semesters. That said, I have to lower down my expectation. So for this lab, I'll try my best to make sure you understand the very basic knowledge of electrical troubleshooting and also construction. But of course, limited to simulation lah. Nak jumpa face to face tak boleh. And then the one that you'll be using for control for motor ke apa ke, nak gerakkan apa-apa ke, ialah digital pin. This is the important pin yang korang akan banyak main lah. Digital pin. And if you see digital pin tu dekat dalam gambar tu, dia ada paling bawah tu 0 and 1, TX, RX. That is what we call as serial communication devices. So typically kita akan connect LCD or maybe wireless transmission ke via here. And then kalau tengok dekat gambar tu juga, pin 11, 10, 9, 6, 5 and 3. Dia macam ada cacing kat depan number dia tu. That is what we call as PWM. So those pins, kalau korang pakai motor, any kind of motors, those are the pins yang korang nak tengok, nak cocokkan ke motor. Make sure motor tu korang boleh control the speed rotation of the motor. Gunakan pin tu lah yang dia dah mention tu, ada banyak tu. So that means after all said and done, I mean ada satu lagi, tak silap saya ada 2 pin lagi yang memang didedicatkan untuk interrupt function. So I can't recall which one, but data sheet adalah. But if tolak pula yang interrupt function tu, actually korang hanya ada pin 2, 4, 12, 13, 8 dengan 7. So tak banyak lah. And you have to remember, nampak je banyak tu. 2, 4, 8, 7, 11 tu. When you connect contoh LED, LED pun ada kaki, positive and negative. That means you have to put in one fit typical application lah. Tapi boleh je sebenarnya pakai satu pin. But typically, kita boleh assume 2 pin tu digunakan untuk one device. So that means after tolak all the PWM, after tolak the interrupt, kita bahagikan yang available untuk pin tu kepada 2. So sebenarnya korang ada dalam around 3 pin saja yang boleh digunakan untuk control anything. Nak control lampu ke, nak control aircon ke, nak control kipas ke, 3 pin tu je lah yang korang boleh pakai sahaja. Untuk UNO, kalau korang ada banyak sangat nak try, better beli Mega lah. Mega ada, tak cakap saya, 20 pin. 20 pin yang korang boleh guna. Bukan 20 pin available kat digital pin. 20 pin yang korang boleh guna untuk any kind of process. So again, Arduino Uno ni dia have different size, form factors, power consumption, availability because of demand macam tu lah. Yang saya pengen bebel sorang-sorang tadi tu. Okay, dan kita tengok macam mana nak codekan microprocessor ni. So, kenalah pakai Arduino IDE. So, Arduino IDE ni memang spesifik khas untuk Arduino. Tapi tak silap saya, FRDM KLMZ board pun boleh juga pakai Arduino IDE. Correct me if I'm wrong. Sebab Arduino IDE sebenarnya interface je berbeza. Tapi coding dalam tu is still C programming. C dengan C++. That's why kita orang ajar you guys C waktu SEM 1. Sebab if you broke everything punya coding dalam available dalam dunia sekarang ni, tolak yang basic, tolak yang mak bapak kita punya coding dululah sebenarnya semuanya C programming, ataupun C++ programming. C atau C++, antara dua tu je. Tak kisah Java ke, Python ke apa ke, semua tu sebenarnya hanyalah C. So kalau korang pegang C, the world is at your fingers. Of course, you have to have creativity lah to come up with a product. But if you have that technical expertise, the world is your oyster. Okay, so peganglah si programming, jangan pandang rendah. I know you guys are EEE112, but being in electrical power engineering doesn't mean you guys don't have to know coding moving forward. Sebab even Petronas pun sekarang dah start renewable energy, and hari tu I think last year kot TNB sibuk kata nak masuk internet provider ke something, saya tak ingat benda. So bukan saya nak kata apa dia akan berubah ni, tapi changes will come, and a simple basic knowledge of only one part of your, even saya punya kawan pun yang sekarang kerja TNB dan dah berpuluh tahun kerja TNB pun, dia pun seronok main Arduino ni. So sebenarnya have fun lah Arduino ni. It's a, you can create games pakai Arduino Uno sebenarnya if you have the creativity. I don't. And beside saya lebih kepada AI. So saya gunakan untuk AI lah. Benda kecil, murah, tapi saya boleh gunakan untuk AI. Power zaman sekarang ni. Sorry tekak saya tadi. Saya minum break.
Get well soon, sir.
Yep, apa question? Ada question ke? Dah tak ada.
No, sir.
Right. So Arduino IDE ni is a free open source. Korang can just download it from Arduino CC software. Dia issue saya dengan Arduino ni dia tak self update. So if you download it, if you want to re-download yang the latest one, if let's say lah korang ada an updated port yang korang nak support, either you guys can download the driver only or download terus IDE ni one whole shot. So every single time you need to do it on your own. Dia tak manually update macam Windows kan. But some people prefer it that way lah, in the sense of security and that private data semua tu. So bagus lah kot. I don't know. For me it's a bit leceh lah. Tapi lah kata hacker. Okay, so this is the framework. Sorry. Hold on. Why, tak puasnya rasa. Nak bersin tapi tak bersin. 3 kali lah ni. Okay, so
Get well soon, sir.
tak apalah. Thank you. Anyway, this is the interface. Kalau if you guys remember waktu korang belajar C programming dulu, dia ada header, dia ada body, INT main. The same thing goes here lah. Dia ada void setup ni is basically your header. Void loop ni is the main body. So jangan nampak pelik pula. Kenapa ada void setup, void loop, kata C programming. Ni C programming lah ni. Dia cuma bentuk dia lain sikit. Dia punya heading dia tu. Tapi kalau awak taruh header macam C programming pun jalan je kat Arduino. Don't worry. Okay, again, I need to speak in English. Okay, yang lain-lain ni saya tak nak kritikalkan sangat sebab saya nak masuk lab ni dah 3.30 ni. But basically what I'm trying to say, what yang the thing that you can take out from this panjang-panjang ni, yang 01. 0 maksudnya off, 1 maksudnya on. Sorry, English. So if it is 0, we call it off because anything times 0 will always be 0. Where if you 1, if you give 5 volt, 5 times 1 will always be 5. So that's why 1 is always on, 0 is always off lah. But that's only digital punya ni. So that's why tadi saya kata bahasa digital 01100111 tu, because of benda macam tu lah. Basically bila dia 1 sama ada 3.3 volt or 5 volt or whatever volt that you need to use for your application. But 0, regardless, macam saya cakap tadi, anything kali dengan 0 will always be 0. Okay. And korang boleh guna interface kan Arduino ni with any kind of sensors or output peripherals, LED, relay, macam ni lah yang dia mention ni, untuk control korang punya circuit. And each pin has been labelled So if you look at the Arduino pin yang tadi tu, nampak digital pin ni ada nombor 0, 1, 2, 3, 4, 5, 6, 7, 8. In fact ada cacing tadi tu. Itulah dia label-label untuk indicatkan PWM yang korang boleh guna untuk control motor. Okay, itu saja yang nak cakap kat sini. Tapi ini actually is a very important information juga yang korang kena letak dekat korang punya lab discussion tu nanti. Okay, now kita start the juice of today's punya class, which is Tinkercad. First, klik Tinkercad ni, ataupun kalau tak nak, copy paste lah ataupun type lah. Macam saya suka copy paste. So saya copy, saya paste dekat atas ni. And then saya login gunakan Google account saya. Saya pakai Google Office saya. Tapi saya tersilap hari tu, saya pergi tick that they can send update and what not. So saya expect lepas ni email saya penuh lah dengan spam email daripada Tinkercad. So my advice to you, first, jangan tick yang bawah tu, yang saya agree untuk terima apa-apa tu. I agree to receive any kind of promotional updates and whatnot tu. Jangan tick. I'm not sure whether you can proceed or not after that, but if ada option kalau boleh proceed, jangan tick lah benda tu. Penuh spam lah email awak. Ataupun guna satu email yang memang korang dedicatekan specifically for office works, yang typically you'll get spam. Guna that kind of email. Disassociate lah, basically moving forward as a human being lah, orang dewasa and a responsible adult in this new age. Always have at least 2 email, one for professional works, one for social works, social events lah. Nak kawan ke, nak email benda-benda yang banyak spam ni ke, on the other part. But yang buat work ni, jangan kacau. Okay. So the first time korang pergi ke Tinkercad, kita belah saya padam yang ni. Saya klik link ni. Give me a second. Okay, OBS show tak? Sekejap je, Windows Capture, manual. Tab. Okay, the first time korang pergi ke sini, tapi saya dah sign in tadi, so dia terus masuk ke sini. So make sure korang sign in lah, sign in create pakai Google email. Kalau tak nak serabut, pakai email UiTM. Sebab korang most probably tak pakai pun email UiTM lepas dah habis student nanti. So pergi ke circuits, and then create new circuits. Anybody ada issue nak masuk Tinkercad ni? Ini paling penting ni.
Before ni pernah pakai
sir.
Sem 2.
Pakai? Oh, pernah pakai? Baguslah, alhamdulillah. Yang lain-lain ada issue?
Tiada sir, setakat ni sir.
Okay, bagus. So mudahlah kalau dah pakai, lagi laju lah. So dia suruh create new circuit and then assemble the circuit as shown. So cari ni Arduino Uno, tarikkan je lah and then rotatekan dia. Saya rotatekan sebab saya nak follow circuit ni lah. But it's up to you if you want to use the same orientation macam yang bila tarik tu, nothing ni pun, cuma I'll try my best to follow the book so that it doesn't deviate much for you guys. So okay, ni since dah pakai, saya laju sikit lah. Ke ada yang nak saya slow down sikit, nanti beritahu je lah kalau nak interrupt je, don't worry, I take no issues with class interruption as long as it related to the subject being discussed lah. Okay, now kita nak pakai 220 ohm, so tukar ni 220 ada ohm. And then LED, dia nak LED warna hijau, so plug it in, change it to green, then rotate it. And kaki bengkok LED ni, apparently kita will have to connect to the end of the resistor. Like this. It's up to you where you want to plug it in, but yang penting connection itu sama. Okay, and then dia nak 5 volt connected to the source of, let me change it to red, sebab biasakan any kind of circuit korang buat, anything yang involve power, live power, put it in red, because red attracts, it gives a sense of apa, precaution lah. Sorry tak cantik saya buat, tapi sebenarnya tak cantik pun tak apa. Okay, connect. Sebab apa tak cantik? Sebab boleh. And then the green one, the black one, you have to connect from ground of the board to the microcontroller. So you can just to the board and change it to black. Ground is seboleh-bolehnya, if you went to the lab, try to use either green or black cable. Color code ni penting nampak remeh, tapi actually it gonna help you so much bila awak nak troubleshoot any kind of error nanti. So you connect this to here, and then somewhere in the middle, kita buat dia macam ni, and this one, kita kasih comel sikit lah. And then sebab ni data punya line, so kita tukar color to maybe blue. And then the other end of the LED, connect it to the ground section, which is over here. And again, when we are talking about ground, as best as possible, I either guna green or black. So senang nampak. So this will be 220 ohm. This will be just an LED, but polarity dia, kaki bengkok tu berada di bawah. And then the other kaki connect ke ground. And then tu je lah untuk circuit macam ni. So try buat. Tak tahu ada yang ada isu ke nak buat ni. I'll give you 5 minutes. If anybody has any issues, let me know. I'll try my best to help you guys. Don't be, jangan malu-malu lah
Okay, sir.
Boleh? Anybody have any issue?
No, sir.
Okay, then but I have to double check lah. Macam selalunya, typically in my class, girls dia not to say bukan, I'm not trying to be a sexist lah, tapi typically perempuan is a bit lagging lah bab-bab macam ni. So I want to double check dengan perempuan dulu. Korang okay ke?
Okay, sir.
Okay, so kita move on to the next ni, which is coding dia. So to code, just click on the code editor atas tu. Then it will bring you to this, and then instead of blocks, this is for kids lah. Kita bukan kanak-kanak ni lagi, so kita tukar kepada text. Sorry. So since kita just pasang LED, so dia predict kita nak buat some sort of LED punya function, so dia siap-siap terus letak draft untuk control LED punya code. And in fact, kita pun memang nak pakai lebih kurang sama, cuma ni lah, ada perubahan lah sebab kita connect to pin. Kenapa panjang, kenapa besar sangat kod ni? Tak boleh kecilkan ke? Kenapa dia macam? So, saya nak, tak boleh. So, kalau kita tengok kod ini, dia ada all the apa nama? Comment ni. It's up to you nak buat ke tak. For me, saya dah biasa, so I don't need to put it in lah. But for those yang tak biasa coding macam ni, I advise you at the first few projects, taruh je yang komen-komen ni. Tak susah pun, just type je. Apa, so that you guys are able to see the flow of the coding. So macam ni, kalau tengok lebih kurang je. Blinking LED ni, komen tak payah abaikan. Dia boleh pakai double slash ataupun slash asterisk. Selalu jarang lah saya dah jumpa orang pakai slash asterisk. Except for somebody yang suka cantik-cantik. But for me, a practical person, I'll typically use double slash and then comment whatever I want to comment lah. So contoh ni saya tak nak comment, I don't want to comment anything, so saya padam lah. Macam for those who want, slash, ikutlah. Thinking LED project. Simple. Siap. And then void setup, dia suruh pakai pin 13. Oh, sorry. Akhirnya. Okay, so pin 13, and then we put pin 13 as output. But if you recall, kita sebenarnya bukan connect to pin 13, kita connect to pin 8. So it's up to you. Kalau tak nak ubah kod yang ini, alihkan je pin 8 ni ke pin 13. Or if awak nak maintain pin 8 ni, tukarlah instead of pin 13, tukar kepada pin 8. This one reflect ni okay, dia dah jadi pening dah ni. Saya kena refresh balik. Bentar give me a second. Macam saya tak nak ubah. Saya nak maintain dia dekat pin 8. Oh, sorry. So I'll just change my coding lah. So instead of pin 13, saya pakai pin 8. Because I terminate my apa nama? Input data tu from from the resistance to the pin 8. And then the same goes downwards lah. So if you choose this as pin 8, so dia punya ni pun semua pin 8 lah. Okay. So nothing change except for the pin number je. Yang high low sama, delay pun sama, so saya tak nak ubah lah. Yang komen-komen tu it's up to you nak ikut ke tak. Bagi saya tak lah kot. Saya dah biasa nampak. Ni yang basic punya ni. Okay. saya try dulu in case yang apa saya buat ni maknanya saya tak perform ke, kod saya salah ke. So saya try dulu. So saya just dah siap kod ni, saya just tekan start simulation. If there's an error, you'll be seeing it here lah. So as you can see, ni saya punya result eksperimen saya, dia berkelip. 1000 maksudnya if you didn't specifically mention you want to measure the timer to be operating in microsecond, millisecond or seconds, in default, Arduino will use microseconds. So 1000 microseconds will equal to 1 second. So that's why you see the blinking here in terms of 1 second. So 1 second on, 1 second off, 1 second on, 1 second off. That is why if you change this to another value, which we'll be doing it later, you will see the difference in the blinking punya the blinking punya sequence. But for now, kita tengok yang ni dulu. Anybody has any issue?
Tak ada, sir.
But of course yang tak ada tu alhamdulillah, bagi saya baguslah, yang maknanya adalah orang yang terror elektronik ke dalam kelas saya ni. Tapi yang maybe tak siap lagi ke? Nak saya tunggu dulu ke?
Dah saya.
No, Alright, sebab ni senang, so kita boleh move on lah kot. Okay, make sure korang dapat ni sama-sama macam saya. Berkelip ni. 1 second on, 1 second off. The same thing kalau if you had the chance pergi tengok in physical nanti, bila korang ada Arduino board korang sendiri, sama je connection dia macam ni. Cuma wire tu tak adalah berbengkok-bengkok macam ni. Up to you lah nanti kalau most probably berselirat lah sikit yang first circuit korang. Tapi bila korang cocok what you call this USB ke dalam USB port ataupun DC male kepada DC jack in ni, dia punya operation sama. Yang lain-lain ni atas motherboard, atas breadboard atau wire jumper semua memang sebiji macam what you'll be doing in the physical form nanti. So inilah. Okay, and then start simulation. Okay, so make sure korang boleh able to understand the code, why it perform, why the code resulted in the LED to react that way. So for me, if I were to use my own words, is because we define pin 8 as output, and we alternate between high and low, meaning at a certain duration it will turn on, and then it will turn on because we define it is at 1000 delay. So that means it will keep turning on for 1000 millisecond. Sorry, microsecond. Milli ke micro? Millisecond. And then after that it will turn off again for 1000 millisecond. So that is why it is blinking from on 1 second, off 1 second, on 1 second, off 1 second, because of we've defined it to be at pin 8, high and then low. High, sustain high for 1000 millisecond, and then sustain low for another millisecond. And since we didn't define any termination of operation here, that's why it keeps on repeating. So this is void loop, and everything under void loop, it will run indefinitely sampai habis bateri, sampai tak ada power source. So it will run indefinitely unless you mention here end of operation. End ke apa ke, nanti dia tutup lah. Jangan sekali je lah daripada atas sampai bawah. Okay. So that's my definition. Up to you. Kalau awak ada tambah your own words, it's much better. Again, remember, short report is your definition. Markah awak. 73.5 tadi tu, based on benda-benda ni lah yang saya akan observe. Okay, part B ni saya nak tanya-tanya orang, so tak apa, kita buat dulu. But kalau baca part B yang 1 dengan 2 ni, basically the same thing yang kita buat ni, cuma dia suruh modify the code to make the LED blink for a different amount of time. So yang this one you have to save it up first. This one code ni dengan gambar ni simpan buat record for your short report dengan code ni untuk part A. Now part B yang bahagian satu dia suruh modify code ni to make the LED blink for a different amount. So macam mana nak modify? Ni lah nak control dia punya blink dia tu, nak kasih laju ke cepat ke. Tadi slow 1 second 1 second. Kalau kita buat 10 millisecond. Apa jadi? Oh sebab laju sangat. Tak nampak beza. Dia kata sebab 10 millisecond. We are not talking about 10 second. We are talking about 10 millisecond. So kita tak nampak. So kalau tak nak, sebab tak nampak beza, kita buatlah sini maybe 1000 lah balik 1000 pun tak nampak rasanya. Cepat sangat. Buat yang low ni 1000. Boleh tak? Dia punya clip tu nampak macam cepat sikit dia punya, macam tak sempat on, dah kena tutup. So, how you want to modify this? Itulah, control via delay tadi tu. Untuk control, kasih dia lain sikit dia punya blinking tu. Okay. So, dah menjawab and dah observe. Saya dah cakap sama tadi tu. Okay, next, create new project, assemble the circuit by adding one more LED. So, bagi saya, again, programmer, bagi saya, prinsip hidup seorang programmer is pemalas. So, kita stay true to that. And in order to become pemalas, kita kena, bukan sebab malas sebenarnya, it's about being efficient. That's the programmer code yang korang kena live by. So, Ctrl C, dah select tadi tu, Ctrl V. Kenapa kena Ctrl C, Ctrl V? So that property yang korang nak ubah ni tak lari jauh daripada yang original. So maksudnya kalau perintang ni pakai 10 km ohm, sepatutnya sini pun samalah. Tengok 220, 220. So mengelakkan kesilapan minor, kesilapan lah maksudnya. Kalau atas ni dia pakai icon sama, sebab kadang-kadang icon tu nampak je sama, tapi apparently dia punya properties berbeza. So that's why it's always best practice to just Ctrl C and Ctrl V. So, okay, dah siap yang tu. Now kena tarik wayar yang ni pergi ke pin. You have to go to pin 12, which is over there, pin 12. Yep. Alright. And the color, since this is data, we don't want to confuse this with ground color. So maybe we'll change it to orange. Okay. Siap circuit yang nombor 2. Saya relax dulu. Tunggu korang kecap saya bagi 5 minit. Sebab tu work smart kalau ikut cakap dia ni, kena buat projek baru, create new LED apa semua, buat apa? Adjust lah yang kod lama yang kalau dah save yang lama tu, adjust yang kod lama tu, tambah je ni. Dalam 2 minit siap lah. Saya tengok ni ramai juga yang dah ada kat kampus ni. Sebab tengok Wan Muhammad Akil, Ahmad Ashraf, Firdaus Hakimi ni macam satu bilik je ni. Dengan
Yes,
Afiquddin.
satu bilik.
Baguslah, seronok. Belajar sama-sama. Jangan asyik online game je.
Macam ni.
Okay, semua orang okay? Saya proceed dengan coding, boleh?
Boleh Cik.
Alright. Okay, now ni panjang sikit. Tapi macam saya kata, kita efficient. Kita jaga lemak-lemak kita ni. Jangan gerak banyak sangat. So, kita Ctrl C and Ctrl V sahaja. The same thing goes over here, I think. Ya, betul. So, this one padam dulu. Be smart Kita tak nak ada wasteful activity. Sayang lemak kita. So, right. Now, dia suruh kita ubah code. Sorry, kita cakap English. We have to modify the code so that it reflects the one that is being mentioned here. So, pin mode 8 is the output. Since we have been using pin 8 as the output. So, done. Then, kita tambah pin mode 12 as another output to connect to LED 2. So digital write, the first being pin 12 high, pin 8 low, okay, delay 1000, okay, we are already there, and then pin 12 low, pin 8 high. So basically we substitute the LED so that it sort of like a police siren, I guess, in a way. So let's see if I code this correctly. Start simulation. Alright, there's something wrong here. Oh, high is in nampak small caps, big cap is important in C programming in Arduino because dia dah masuk dalam library dia high huruf besar. Library dia yang dia pakai reference lah So make sure you, sebab tu saya Ctrl C, Ctrl V sepatutnya mengelakkan kesilapan-kesilapan macam tu lah. So, there you go. You see the blinking is like a siren of a siren, fireman, fire engine, bomber semua tu lah.
Sir, saya nak tanya sir. I want to
Tanya.
ask you something sir.
Yes, please.
Macam mana, dia 12 dulu, 8 dulu ke tak kisah sir kan?
If you change 12 and 8, what happen is, if you see at the code here, so dia punya blinking tu, siapa yang first lah basically akan jalan dulu. So kalau macam ni 8-12, saya buat 8-12 pula. Nanti instead of green or red menyala dulu, the other one lah akan menyala dulu. Tu je, nothing much.
Oh, okay sir. Thank you sir.
Alright. And you have to remember when we are talking about coding, C programming, dia mengalir macam air. Maksudnya atas ke bawah. So dia takkan, unless of course macam ni. Saya letak 8 dulu, lepas tu 12. Tapi bila saya buat digital write, I put the 12 first and 8. So 12 is the one yang this one, yang merah ni dulu. Okay, let's say saya stop ni. Saya tutup kod ni. So I expect, since saya start dengan kod ni dengan 12 is the first one to be high. So if I start the simulation, I expect nampak red nyala dulu. So if let's say I stop this, I changed it to 8, 12, and then 8, 12. So now I expect 8, which is yang bawah ni dulu, hijau menyala. Tu, hijau menyala dulu. So, what I'm trying to say here is that dia mengalir macam air, betul. Maksudnya kalau awak tak define, dia akan start dengan pin 8 dulu lah. Tapi macam ni, saya dah specifically ask the microcontroller to keluarkan 12 tu dulu first, baru pergi ke 8. The same thing, 12, 8. So, sebab tu merah tu menyala dulu. Sebab 12 kita bagi tahu dia atas ni jalan dulu. Alright, so yang ni saya tunggu siap dalam 2 minit dan sambil saya nak tengok siapa yang saya boleh panggil untuk present dia punya finding. Okay, yang ini saya nak minta maybe Ahmad Irfan dulu. Kamera tak turn on, saya nak tengok buat ke tak tu. Ahmad Irfan, can you present to me I understand some of you might not have a camera, but at the very least, you guys can present via your computer or laptop on the circuit that you've been doing. So, minta Ahmad Irfan share your presentation with the class.
Ya, sir.
Okay, boleh.
Sir,
Yes.
kan dekat Arduino tu kan dia ada nombor yang negatif tu kan?
Arduino ada nombor negatif.
Yang negatif dekat tu, yang negatif 11, negatif 10 tu.
Oh, that one is not negative. Itu yang saya cakap tadi cacing tu. Itu PWM pin. So if you have a motor, you want to speed up or slow down, pakai pin tu lah untuk control. Speed down, slow down, also speed up.
Okay, sir.
Alright.
So,
Yep.
yang part B, I can't get the second. Yeah.
Part B, you can't get what? Sorry, putus-putus.
Yeah. Can you see, sir?
Now give me a second. Okay, yeah, alright.
I can't ni. Yeah.
You can't pin mode
There's something
in
wrong, sir.
output. Yes, because you're supposed to have hold on, give me a second. You're supposed this one is for part B, item number 4, right? Step 4, right? The code,
Yes.
the one that we are doing right now. So you can see that your pin mode is only on. You already new one. Okay. Red. Do you have any other circuit in this project that you have right now? No.
No, just
Just this one, eh? Okay. Hold on, give me a second. Positive, negative. Alright, ground. Source. Okay, nothing wrong there. 812 bit mode. Output 12. Mana? Tak nampak. Yang tadi tu. Yang padam. Ah. Pin mode 812. Output. Betul dah. Kenapa dia macam blurry? Alright. 8 high. Oh, nah. Delay. If you see there under digital write 8 high, there shouldn't be any delay down there. You
No.
will only have delay at the bottom of digital write 12. The same goes with the bottom part. Delete that delay.
Wait, this one.
This one, that one. Delete that, and then the second line. That one under digital write 8. Delete that. Okay, now try run simulation. There, it works now. But why is it only the green light that is working? Oh, you have to change the digital write 8, the bottom one, to low high.
Low high.
Line 15 is supposed to be digital write 8 low. Low, and then the digital line 16 high. So that way it will ni lah, terbalik lah. Okay, try start. Now it should yeah, swap. So again, just biasalah coding ni mula-mula. It is a typical beginner mistakes lah tu. So don't worry so much. But I'm still waiting on Ahmad Irfan.
Hello, sir. Oh, saya tengah present.
Huh?
Can you see my?
Oh,
boleh tengok present.
Oh, yang tadi tu orang lain. Okay, sorry.
Oh, okay.
Alright. Ni Ahmad Irfan punya ni. Tadi yang share siapa tadi? Okay, tak apa. Never mind. Okay. Amin, alright. Never mind. So it works now, right? Ahmad Irfan?
Yes.
Alright. So okay lah kot Ahmad Irfan. Okay, maybe next one I want to see on the girls side, Nur Fatihah Noldin. Can you share with me your simulation?
Yes, sir. Present.
Present.
Sir, nampak tak, sir?
Tak ada lagi. So far
Sebab
not
saya
yet.
dah
Nothing yet.
present.
Dah present, but even iPad saya pun tak capture anything. Have you clicked the present now?
Yes. I already clicked it. And I present a tab.
There are nothing so far. You present a tab. Maybe you can try present a window, and then select your Google Chrome punya tu.
Sir, can I left this Google Meet first?
Yeah, try please.
Wait.
Is Nurin Iza sitting next to siapa tadi? Yeah. Sebab nampak macam borak-borak sebelah je.
Sir.
Alright, okay. Don't worry so much because we have plenty of time, and in fact this will be the second last, and the last one will be much easier. But yalah, tunggulah kawan awak tu. Oh silap, bukan easy, banyak juga sebenarnya. Tapi if you have tackled this one, shouldn't be a problem lah, part C. Are you guys, Nurin, are you guys in college? Data okay ke?
Okay, sir. Okay.
Sebab kita nak buat ODL penting data. Okay, so you'll just start your simulation. I want to see whether you are able to achieve what had just been discussed.
Sir, my LED
Yep.
did not blink.
There? Yeah. Okay, can you start simulation? Can I see the code?
This is the code, but it didn't blink.
Okay, give me a second. Oh. Betul dah.
Oh, like that.
Yeah, it blinks.
Oh yeah, it blinks.
Oh no, is it blinking? Because it seems it's too.
It's quite late.
Yeah, supposedly for 1000 milliseconds, it shouldn't be that long. Sekejap, let me see if there's any mistake. Delay dah betul. 12 high, 8 low, 12 low, 8 high, betul dah, digital right. 8, 12 output. There's no problem there. Is it because, can you see the tab? I can see another tab there, circuit design. Tinkercad, there's 2 tab on circuit design. Can I see the next tab?
Oh, this is for the part C, but I haven't finished
You
it.
haven't done anything. Maybe there's an internet issues between the servers. So can you close it down first, the part C first? I want to see whether it affects.
Yes. Still the same.
12, 8. I don't see any problem with your code, but I think it's more on the Tinkercad side of code. It's not your problem, I think. It's more on the lagging between data transmission code. So never mind. But the thing is, it does blink, but the timing is a bit off, even though only 1000 milliseconds. So okay, never mind. Good job. All right. So now we'll be proceeding with the next part C. Right. So part C mentioned that we need to include switch. So to include switch, first, I guess we have to delete this. And also, is it this one? No, we'll wait. So push button. Where is it? This one. No. Where's the push button? Okay, the pening. Give me a second. I refresh the connection. Okay, one push button. All right. So this push button, if for those who might not know, the way breadboard works is that is as you can see here, if we click not click if we hover the mouse pointer on top of one round area, you'll see that it's connected for this side in a vertical way, where the same goes to the negative side. But within the board itself, this one is horizontal. Which one is horizontal? This one. This one is horizontal. But if there's a breach, it will not be connected. You can imagine there's a copper strip underneath these pinholes here. So there's a connectivity between this horizontal line. The same goes with the other side of the bridge. And for the power, again, it continues to be straight. So this hole here is actually connected to the end of the hole on the other side. The same thing goes negative side. Vertically, it's connected to the other end of the holes there. While for the, let's say, column 2, A, B, C, D, E, you can see that 2A is actually connected to 2E. The same goes to F with 2G, J. So that's it. If you want to use a switch, you can either rotate this, but if you don't want, like what I'm doing right now, you can just do it like this. Connect the pin of the switch to the board itself. Maybe change the color to make it easier to be seen. This one to maybe pink. So that's how the connectivity between the motherboard goes. So remember, dulu waktu saya diploma dulu saya tak tahu sampai ke sudah, sampai dah grad saya tak tahu macam mana nampak board dia. Dah masuk degree baru tahu. Malu lah. Okay, so again, being efficient punya person, kita control C, kita control V dia. Even though simbol tu nampak sama, but to reduce the possibility, we have been using we will be using a different sort of switch. So kita control C, control V je lah. Okay, this one kita tukar color kepada brown. Push button switch ni panggil. So now we want to change this 5 volt to another side. Hold on. To this side. And at the same time, we want to give power supply from is either to the, you can put it either on the leg of the switch itself or anything in between row 27, F, G, H, I, J. Is up to you lah, because everything is connected there. And since this is a live wire, I prefer to use red jumper. The same thing goes here. From positive terminal 5 volt DC to the terminal 2B of the switch wire, switch fit. And then now, since it requires us to use 1 kilo ohm, so we need to change this to 1 kilo ohm. Just change the property. And then again, being efficient, Control C, and we Control V, and put this connected to the ground to the bottom fit of the switch. The same thing goes here. Lama dia letak macam tu ya. Lalu ini kita alihkan ke sebelah sini. Okay, so complete this one. And then both of these pin will go to pin 2 and pin 4. So pin 4 pergi ke the first one, connected to the first one, and then we put it here, Tadi atas. Oh no, 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 no. Okay. Give me a second. June. And then since this is a data colored, so kita tukar dari turquoise. Then next one will be this line here goes to pin number 2. Since we want it to be a bit cheerful, we'll change it to purple maybe. Yep. Siap. Okay, yang the other one, yang LED maintain sama, so tak payah kacau, cuma yang bawah-bawah je lah. Okay, now it is azan here in my area here, so I'll keep quiet for 5 minutes while waiting for the azan. So make sure korang siap yang tu ya. Boleh. Boleh terus continue dengan coding tu eh. Sorry, of course, if anyone has any problem dengan connectivity tu nanti, boleh tanya saya, interrupt me anytime that you want, because ultimately saya nak make sure everyone dapat data untuk korang goreng dalam short report nanti. Okay, saya dah siap code. So, macam saya cakap lah, kalau nak cepat, biasakan guna Ctrl C, Ctrl V. Try to use it as much as possible because just previously when I was teaching the other class, I didn't use the Ctrl C and Ctrl V. What happened was there's a small error involving me using capital letter in digital right. Instead of W, the only thing capital is W. I wrote everything in capital letter for digital right. So what happened was I had to, because something here, chances are will pass over your eyes. You can't even see in detail even though you try. But because of that one simple mistake like that, I took over around 10 or 15 minutes trying to solve the problem. But that is why it's much better if you wrote it once, try Ctrl C and Ctrl V. Unless, of course, if you haven't wrote it, then you need to write it in first time. But moving on after that, you can just Ctrl C and Ctrl V. So, because everything here is being recorded in the library, Arduino library. So if you wrote it wrongly, the Arduino Uno or Arduino IDE processor won't be able to recognize them. So, okay, enough of that. Now we look into the output. So as you can see, my red LED is on. My green LED is not on, is off. But if I hold the switch button, now red LED is off. And I hold the second switch button, now the green LED will light up. Okay, reason why nanti saya akan elaborate lah. Kenapa code, kenapa dia bekerja macam tu based on the code. But for now, I want to make sure everyone achieve the same result as I am.
Sir, I
Yes, Rahman.
cannot see the code, sir.
The code, or because it is blurry or what?
Yes, sir.
M-
Blurry.
Maybe I can try to zoom in. My advice is, after this, try to open your lab manual on your side also, juga lah. Because dia depends on data benda ni. Kalau saya punya high end data saya 100 Mbps, nampak clear je from my side. But of course from your side, kalau data awak tak ni, chances are no matter how clear I put, takut tak nampak juga. So it's best apa, kalau tak nampak tu buka lab manual tu dekat dalam awak punya handphone ke apa ke, and try to look at from there. Itu jimat masa awak lah takut saya tak perasan ke apa. Nampak muka saya Oh, what I can do is like this. Susun ni. Give me a second. Alamak, silap. Sorry. Where is OBS? This one, alright. So my ugly mark saya letak tengah-tengah. Okay. Okay, saya tengok macam some of you have managed to finish everything. So nak minta maybe Adli Hakim. Can you present your findings, whether it works the same as me?
Okay, sir. Can you see, sir?
Yeah.
Oh, okay. Okay, I start press this.
Right, it works. Okay, good. Bagus. Okay, another person. Thank you, Adli Hakim. Next, maybe I want to ask perempuan pula, Nur Atika Syafiqah. Can you please share with me your result of your simulation? Are you okay, Nuratika? Boleh.
Can you see it here?
There's nothing so far. Present a window maybe.
Wait a minute, sir. My laptop
Okay.
is a bit slow.
It's okay. Take your time.
Sir, I have a question.
Yeah, please.
Apparently my code is not working. It says
Can
that
you share?
button. Okay, sure.
While we wait for Miss Nur Atika, maybe we'll look at Miss Nur Irdina first.
Can you see it, sir?
Yep.
So when I start the simulation, it says that button state 1 is not declared.
Hey, you got a similar problem with me. Okay, give me a second. To confirm, need to open this. Or is it this one? Sorry, hold on. Give me a second. Where's the presentation? Tak nampak.
Tak nampak. Saya tak nampak ke yang saya present?
Yang awak present. Tadi ada.
Oh,
Okay, ada. Sorry, ada di sini.
okay.
Kenapa dia... Oh, my layout ni problem ni. Hold on. Where is it? Like that, auto. Spotlight. Sidebar. Child. Apa tadi? Tak, saya pin awak benda ni. Okay, button state 1, digital read button 1. Button 1 aku ada declare betul. Button state 1. The error was not declared. Button state 1 was not declared, whereby awak dah declare kat atas tu button state 1. Is it possible awak salah eja button state 1? Betul dah. Was not declared. I do declare. To 1200. Can you try to control C the button state 1 and button state 2 and paste it on the button state 1 command at the void loop?
This one.
The orange colored
Okay.
button state 1. You replace it. You copy the top one first. I'm afraid there might be some yang int line 5 tu, int button state 1. Ambil yang button state 1 tu je.
Okay.
Control C. Okay, and then paste it up. Paste it on the button state 1. Okay, try start simulation, tengok ada berubah tak. Tu jalan.
Oh, okay. Thank you, sir.
We going back to Miss... Siapa tadi? Lupa dah saya. Atika ke? Nur Atika Syafiqah. Please share with me your result.
Wait a minute, sir.
Okay, take your time.
Can you see it, sir?
I can see it, yes, now. Right. Can you just start the simulation? I want to see whether it runs. Can you press the button? Because I can't see the red button is... no. No, just press this button. Press the switch. Nothing working. And the other switch? Pun nothing working. Can I see your code? Your code is not... I mean, you haven't haven't finished it yet, right? Is it? Or is this the wrong
Yes,
code?
because my laptop is lagging just now.
Okay. Never mind. Make sure you finish this up. Because ingat ni saya ambil markah juga sebenarnya ni. Okay, so what happened here? Okay, thank you, Miss Noratika. Now I continue with my ni pula. Okay, so what happened here? Wait a bit. All right, now I have to zoom it out. Okay, we've mentioned that button state 1, this is button 1, this is button 2. For ni just constant lah, macam kalau belajar C programming tu, the one yang kita letak atas tu. So kalau any kind of changes in the void loop punya area won't affect ni lah, won't affect dia punya original value. So we want that to stay maintained. Pin 4, pin 2, pin 8 semua maintain as per apa ni. So tak nak ubah apa-apa. So kita declare as a constant lah kat atas ni. So nothing much here. And then since kita tak nak guna tak nak confuse, so kita declare button state 1 tu, ni button 1 ni mula-mula kosong lah. So kalau kita tak tekan apa-apa, value dia kosong. Even though physically kalau kita tekan, kalau awak boleh imagine macam ni jalan, and then bila dia masuk sini, this is a roundabout. So kalau kita tak tekan push button ni, awak boleh imagine roundabout tu being lifted above the ground lah. So kereta tak boleh lalu. So even though in physical it is like that, meaning kalau awak tak tekan, itu maksudnya kosong. Tapi bila kita tekan, and then bila kita tekan jadi satu. Tapi the same thing goes here lah. So initial state dia, initialize, kosong. Kenapa saya kata tapi? Disebabkan kita tak tekan dia jadi kosong. Bila kita tekan jadi satu. So sebab tu kat sini kita declare initial value dia kosong lah. Sebab sekarang ni kita tak tekan, kosong lah. Cuma awak maybe akan confuse kat sini high ni nanti. But bear with me for a bit. Okay, ni just pin mode. Nak bagi tahu button 1 which is pin 2, button 2, pin 4, LED 1, pin 8, LED 2, pin 12. Sorry, database cakap Melayu balik. So basically what we are declaring it there is as pin 2 and pin 4 as the input you get from your switch pin ni, the switch button ni. And LED tu as the output as a result of the input that you, to reflect the input that you set here lah. Okay. Ingat ini akan menjawab awak punya discussion dekat yang bawah dalam lab manual tu. So void loop ni, bila dah jalan, this is the main body lah. So bila dah jalan, dah declare semua atas tu, this is where we control the Arduino. So mula-mula dia check, baca dulu, read dulu sebab kita connect dekat pin digital. So digital read button 1, where button 1 is pin 2. Kita suruh baca pin 2 dulu lah. And then kalau dia punya position is high, now even though nama dia high, tapi sebenarnya value dia kosong, logic dia kosong. Kenapa? Itu saya nak minta awak explore sendiri. Saya nak awak, at the very least, tak naklah semua saya swap kat awak. Adalah benda yang awak fikir sikit. So, tapi even though dia kata high kat sini, it is actually the value of analog tu kosong. And then, kalau position dia high, which is currently, kita tak tekan apa-apa, dia high, LED 1 should be also high, should also be turned on. So, basically, cara cerita dia, current mengalir, tapi disebabkan dia high, kita tak tekan, so current tu start kat sini. So, bila current start kat sini, dia bagi output kosong dekat kaki ni. Bukan kaki 22, 23 ni, sebab kaki 23 ni tak connected to mana-mana, so tak mengalir mana-mana lah. The same goes with kaki 26, tak connected to mana-mana. So, the current will end up flowing to terminal 1A. Kalau awak hover kat sini nampak 1A tu, dia mengalir ke terminal 1A, tapi disebabkan tak tekan, so circuit tak lengkap, so tak ada value lah kat sini. So bila tak ada value, basically kosong lah. So bila kosong, and then you have to remember, data ke current ke whatever, dia akan mengalir dekat kawasan yang laluan yang tak ada halangan. So macam awak juga, awak tahu ada 2 jalan nak pergi tempat kedai makan ni, nak lepak dengan kawan. Satu jalan ada roadblock polis, satu lagi tak ada roadblock polis. So of course, saya would expect, tak kisah jauh mana pun wayar awak tarik tu, awak akan pilih jalan yang tak ada polis. So macam tu jugalah, ni resistance ni macam roadblock polis lah. So dia tak nak lalu kat sini, dia nak lalu dekat pin 2, sorry, this one, pin 2 yang green, purple. So pin 2 dapat value kosong. Sebab circuit tak lengkap, current tak boleh lalu kat dia, dekat pin terminal 1A ni. So what happen is, kosong lah value kat sini. So kosong jugalah yang diberi ke pin 2. And considering pin 2 is supposed to be connected to LED 1. So LED 1 is pin 8. Ni pin 8. So pin 8 ni dia jenguk pintu, berapa signal yang dia bagi. So it turns out signal pin 2 is 0. So 0 kita set kat sini, which is 0 in the sense high lah dalam coding ni. Maksudnya kita bercakap pasal 10 tu, kita bercakap pasal position button yang hitam tu, yang push button ni, kita tak tekan dia kan naik lah dia kan. So kalau kita tekan dia low, but now it is high. So bila dia kata okay kosong, that means kita kata kalau LED kalau pin 2 tu kata kosong, kita suruh LED tu menyala. So 8 punya pin ni dia ambil power daripada USB punya source, again cakap maju lagi, USB punya source, and then it draws the power, bagi current to gives the current to flow through this lane 20, is it? I think 20 to row 20 fit into the resistance. Because why resistance before connected to LED? To make sure that there is no overcurrent. LED can only operate to a certain small amount of current. If we fed directly to the LED, chances are, which is typically historically memang banyak berlaku dah pun dekat lab, meletup LED sebab student lupa letak resistance between LED dengan command power supply lah. So make sure ada resistance lah dekat terminal kaki LED ni. So that's the reason why we put LED. So now current lalu LED, so they reduce a bit of power, goes into the LED sufficiently so that doesn't blow up, and then after it has power up the LED, it flows to the ground to make sure the circuit complete. Dia macam air sungai lah, kena ada punca turun ke hulu ke hilir ke, saya tak tahu bahasa Melayu ni, saya tak biasa main sungai, hulu ke hilir yang hujung itu, and then air hujan sedut balik, matahari sedut naik atas balik jadi awan, turun balik jadi air. So that's how nature go. Macam tu juga air current, dia kena mengalir balik ke pangkal ground ni so that current tu boleh bergerak. Kalau tak, dia jam, tak menyala lah LED sebab current tu, elektron tu tak boleh nak bergerak, tak boleh transfer charge, so there's no electricity. So kena matikan balik ke ground lah. Kalau tergantung macam tu, dia bertepek-pepek, takut dia pom jugalah meletup sebab overcurrent. Okay, so that's why yang waktu position high, button state 1 high, LED pun menyala. Even though kita tak tekan, dia menyala. Sebab tu nampak yang mula-mula merah ni, dia menyala. Kalau kita tekan, baru dia tutup. Because waktu else ni, if kalau ada if, else lah. Kalau bukan satu, else dia kosong lah. So that means kalau button state 1 kalau sini high, kalau else button state dia low lah, maknanya kita tekan lah. If we push on it, so if they receive, sorry, this one, sorry, this one. So if we press on it, which is else case, we indicate that we should the pin 8 should give off signal to LED. Bukan masuk off signal, maksudnya bagi don't give any kind of power source to the LED. So ni pin 8. Saya tengah buat merah sorry, pin 8 pula, pin 12. So pin 12 dia ambil power source tadi tu, bukan maksudnya dia ambil, dia tutup current supply to the LED, red LED, indicating that there's no current there because we control there. Kita define yang if pin 12 detect pin 2 kata tak ada signal, which is kita sebab kita tekan, jangan fikir pin tu lah, saya dah confuse mana-mana pin ni, tapi basically it receive data from pin, kalau ikutkan ini bukan pin 2 ni, pin 4, sorry, tekan ni pin 4. So bila dia detect pin 4 tu low, which is bagi signal 1, logic 1, maknanya ada current. So kita cakap kat sini, bila position dia low, LED pun low, sebab tu dia tutup bekalan kepada lampu merah tu, LED merah. And then untuk yang lampu hijau, different case lah, sebab kita define if position button to high, maksudnya logic kosong, LED should be also kosong. Bila ada kita tekan button, baru LED tu menyala. Sebab LED dua high. Okay guys, explanation saya tu ke membebel, hopefully boleh capture lah apa saya cakap tu. So that's what you should put on your, give me a second, mana ni, on your discussion section, the next one ni. From your observation of the circuit, what happens when you press any push button? If you press push button, which one this is this 1 or 2? Tengoklah coding tu. Kalau push button ni 2 lah saya rasa ni. So what happen is yang ni akan tutup off. And if you press the second button, the green LED will light up. According to the connection of the push buttons, ini yang saya cerita bebel seorang tadi tu, inilah ni, logic input ni. What is the logic input being sent to the microcontroller when the button is pressed? Saya punya explanation tadi dah jawab ini. So I don't want to repeat. Try to recall balik so that ilmu tu melekat. And then measure the voltage value at the input pin and output pin. Okay, now I understand some of you, or most of you, or all of you actually, haven't been to lab. So I would expect most of you are unfamiliar with using to do voltage testing or current testing, which is quite critical for diploma level punya students. In fact, saya sendiri dulu waktu saya bayar awak tu tak tahu pun macam mana nak measure voltage dengan current sampailah degree. But itulah, ni now saya nak tunjuk dekat awak. Since kita tak ada face to face, so terpaksa pakai simulation, so pakai je multimeter yang ada sini. And since you are measuring voltage, so make sure voltage. And then you have to remember, to measure a voltage, you have to do parallel testing. So to do parallel testing, kaki yang negatif ni pergi ke ground, share the common ground with the circuit, whereby sebab dia kata measure the voltage at the input pin. So this is output pin, input pin and output pin. So kita sekarang ni, saya sekarang ni tengah buat output pin, which is pin 12. So nak measure dia tu, saya tapkan dekat ni. So kalau circuit ni nampak macam parallel lah, saya tap yang atas ni, and then saya tap ground yang sama dengan apa nama, LED dan resistance ni. So you should be able to get your voltage lah. So kalau saya start simulation, dapat 4.85 kalau dia on. Kalau dia off, 0 volt. Nampak? Dia punya satu is 4.85 volt, which is actually 5 volt daripada USB ni. Bukan daripada bukan daripada 5 volt yang you got from the Arduino board, but more sebab ni pin ni dia direct draw from the USB source. So sebab tu 4.85. Basically ni lah 5 volt lah basically. And then saya bagi contoh yang output pin dia. So yang input pin pandai-pandai awal lah. Nak interface which one value dia. So tak naklah saya swap everything. Okay, soalan?
No, sir.
I hope terima kasih feedback, tapi I hope semua orang betul lah faham apa yang saya cakap tadi tu, because that is the basic knowledge yang you guys should know lah. Okay, again saya wonder kalau ada yang ada masalah lagi, hopefully clarify lah kot yang isu-isu yang basic, sebab biasalah kalau buat hardware ni sort of like hardware lah ni kira akan ada isu dengan typo-typo macam tadi tu. So I wouldn't expect you guys to be able to do it in the first fly, but again any question boleh tanya saya. Saya akan try tolong sebaik mungkin lah, to the best of my knowledge. Of course saya manusia, tak tahu semua. Again saya dah cakap Melayu lagi. And any case, again, if you have any question, please ask me. I'm open. The door is always open, provided I'm not doing anything else at the moment. But of course, if you want me to help you, please provide with me the code or the simulation that you've done. So every single result that you have done here, you need to snap it, put it in the lab sheet, and that lab sheet you need to submit via Google Classroom, where I'll be giving you an ample time lah for you to submit. Like I said, macam kelas hari ni, hari Isnin, so you be able to you should submit your short report by Sunday midnight, so that on Monday I'll be able to check who has or who haven't submitted, so that I can appropriately nak bagi markah kan. Okay, other than that, again, interrupt me if you have any question, but if there aren't any, we can conclude our session today with Tasbih Kifarah and Surah Wal-As. Okay, thank you everyone. Have a great day.
Thank you, sir.